Now let's look at solving equations with indices. Now we could have equations that have indices. For example, I'm to solve the following. So let's start with example 1. Here I have 4 raised to power y plus 1 equal to 8 raised to power y. Now this is an equation with indices. So if I have an equation like this, what do I do? Now the first thing you need to pay attention to are the bases. Here the base is 4 and here the base is 8. So what we're going to do is to ensure that these two bases have the same base. So you think of a term, you can express 4 and 8 so that they have the same base. For example, 2 raised to power 2, it's 4. Then you open brackets y plus 1. And again, 2 raised to power 3 is 8. And then you open bracket for y. So you can see you've succeeded in making the left and the right hand side to have the same basis. So once you have these, it's easy for you to cancel out the base since they are the same, and then you equate powers. So I'm going to cancel the base, equate powers, and that's 2 open brackets y plus 1 close bracket equals to 3 open brackets y. Now let's expand the bracket. 2 times y is 2y. 2 times plus 1 is plus 2. 3 times y, 3y. Now collect like terms. 2 will be 3y. This 2y will cross to your right hand side to become minus 2y. It is positive here, and so when it crosses the equal to sign, it becomes negative or minus. 2 is equals to 3y minus 2y. It's y, so therefore your y is equal to 2. That is the answer to the question. Let's try number 2. Number 2 question. I have this. I have 9. Okay, number 2. I have 9 raised to power 3x equal to 27 raised to power x plus 1. So again, the same procedure with number 1. You're going to express the base at your left hand side and at your right hand side to have the same base. Here, 3 raised to power 2, it's 9. Open a bracket for 3x. And here, 3 raised to power 3 is 27. And then you open a bracket for x plus 1. So you can see that the bases are the same. The base at your left-hand side is the same as the base at your right-hand side. Once you succeed in doing that, then you equate powers. So I can cancel out the base. So I'm left with 2 open bracket 3x close bracket equals to 3 open bracket x plus 1. So let's expand the bracket. 2 times 3x is 6x. 3 times x, 3x. 3 times plus 1 plus 3. Collect like terms. 6x, this 3x will move to your left-hand side and become minus 3x because it's positive here, equals to 3. 6x minus 3x is 3x equals to 3. Now we're looking for x, so you had to divide both sides by the coefficient of x. The coefficient of x here is 3, and so when you divide both sides by 3, your value of x will be 1. This will cancel. So this is the answer to the question. Now let's look at number 3. Number 3, I have 7 raised to power 3n minus 1 equal to 49 raised to power n plus 2. So what I'll do is to express the base both at your left hand side and at your right hand side to have the same base. Here's already 7, so it's easier for me to express the one at my right hand side to have 7 as its base. So this will be the way it is, you won't utter anything. Then you express 49 as 7 raised to power 2. 7 raised to power 2 is 7 times 7, that gives you 49. So you open a bracket for n plus 2. So the base are the same. So once they're the same, you equate powers. So you cancel out the base. And then if you do that, you'll be left with 3n minus 1, 2 open bracket n plus 2. So this is 3n minus 1 equal to, now let's expand the bracket. 2 times n is 2n. 2 times plus 2 is plus 4. So at this point, we can call it like terms. I take 2n to the left-hand side. It becomes 3n minus 2n equals to 4. And you take minus 1 to the right-hand side and become plus 1. So note, since it's minus 1 at your left-hand side, when you cross the equal to sign, it will become plus 1. So this is 3n minus 2n, n, 4 plus 1, 5, and that is the answer to your question. And let's try at number 4. It's becoming a little bit complex at this point now. Here I have 1 over 4. This is a fraction now. They are all raised to power y plus 1 equal to 8 raised to power y. If I have a work like this, what do I do? It's also easy. Remember, 1 over 4 is actually 4 inverse, 4 raised to power minus 1. That's it. And so all raised to power y plus 1 equal to 8 raised to power y. Now, let's express this to 10 base to have the same base. This will be 2 raised to power minus 2, because 2 times 2, 2 times is 4. Then your brackets, y plus 1 equals to 2 raised to power 3 y. Now at this point, we can equate powers because the base are the same. So let's equate powers. Now please pay attention to what I'm going to do here so that you don't get confused. I'll cancel the base. True. But note, I'm left with minus 2 here. So you can open a bracket for y plus 1 equal to 3y. It is this minus 2 you use to expand this bracket. So minus 2 times y, minus 2y, minus 2 times plus 1, minus 2 equal to 3y. Now minus 2y will move to your right-hand side and becomes 3y plus 2y. You're left with minus 2, so that's what will be here. And this is minus 2 equals to 3y plus 2y, 5y. So you can divide by the coefficient of y, and then, therefore, your y is minus 2 over 5. That's the answer to your question. Okay, let's look at number 5. 9 raised to power 4 plus x divide 3 raised to power 3 minus 2x equals to 1 over 27. Now place this is plus 4 plus x. Okay, so if I have a question like this, what do I do? It's the same procedure. Express all the terms in the equation to have 3 as its base. So here, this 9 will become 3 raised to power 2. 3 raised to power 2 is actually 9. Then you open a bracket for 4 plus x, close the bracket. Now this is already expressed, so you don't need to touch it. 3 minus 2x equal to. Now, there is something you must understand about this, what we'll have here. But let's still go on. Let's express this. Let's take it one after the other. 27 will be expressed as 3 raised to power 3. 3 raised to power 3 is 27. So at this point, what do I do? Now let's apply what we've learned under the laws of indices. Now 3 raised to power 2 open bracket 4 plus x. This is division. So divide 3 raised to power 3 minus 2x equal to 3 raised to power minus 3. Because this is inverse 1 over. And to take away the 1 over, to remove it, you introduce your negative or minus. At this point, what do I do? You could see that the base are the same. So I could equate powers by cancelling out all the bases. Okay. If you do that, what will it be? It's going to be, oh, okay, I think I need to take one more step before I equate powers. So here, please, do not cancel. It's very important. Don't cancel yet. I had to make sure the only way I could equate powers is to ensure that I only have one of the base at my left-hand side and one base at my right-hand side. So these 3 will stay there. So this will be 3, 2, open bracket 4 plus x, close bracket. Division in indices means minus. Minus what you have here, 3 minus 2x. Put them in brackets, equals to 3 raised to power minus 3. So please, at this point, recall I said don't cancel yet. If we do that, we may not get what you're looking for. I may be jumping a step and you will not understand what I will do next. So you're not canceling. Good. So this is where you can now equate powers and cancel out. Why do I say so? Because here you can easily cancel out these 3. But in this previous step, I was canceling out 1, 2, 3. It's also possible for me to solve and get my answer. But if I take that step, I will jump this step that is crucial to understand solving equations that has to do with indices. So at this point, once you get to this step where you have just one base at your left-hand side and one base at your right-hand side, you can equate powers. So please don't forget this. Before you equate powers, always ensure that the base is only 1 at your left-hand side and is 1 at your right-hand side. But if you check this step, the base is 1, 2, 3. So at this point, do not equate the base yet. Equate the powers rather. So, but when you take the next step, then you can equate powers. But now notice what I did. Division in indices means subtraction. So minus the power. I have here 3 minus 2. Put them in brackets. That way, I will eliminate these 3. And then I have just one base and at my left-hand side and one base at my right-hand side. So here I can cancel out this now. So I'll be left with 2 open bracket 4 plus x close bracket minus open bracket 3 minus 2x equals to minus 3. It's important you put this in brackets because this minus is going to affect everything in the bracket. So let's expand 2 times 4, 8, 2 times x plus 2x minus times 3 minus 3 minus times minus 2x plus 2x equal to minus 3. So at this point, we can collect like terms. Plus 2x plus 2x equal to minus 3. And minus 3 will go and become plus 3. 8 will go and become minus 8. 2x plus 2x, 4x equal to minus 3 plus 3. That's gone. It's 0. 0 minus 8 minus 8. Divide both sides by the coefficient of x, and that's 4. X becomes minus 2. So this is the answer to the question. Okay, this is another example, and it's going to be the last example on the equations with indices. 4 raised to power 2y times 8 raised to power 3y divide 32 raised to power 1 minus y equal to 1. Now, please pay attention to this so that you don't make any mistake. We are going to express all the terms we have there in the equation to have one base, and 2 will be a common base for all of them. So let's start with this. For 4 raised to power 2y is going to be 2 raised to power 2, open bracket for 2y, times 8 raised to power 3y will be 2 raised to power 3. 2 raised to power 3 is 8. Then open a bracket for 3y. Divide. 32 will be 2 raised to power 5. Yeah. 2 times 2 times 2 times 2, 5 times will give you 32. Then you open a bracket for 1 minus y. Equal to. Now here it's 1. You see, we're trying to make everything to have the same base, which is 2, 2, 2. So how do I make this right side of the equation to have 2 as its base? Remember the concept of 0 in indices? 2 raised to power 0 is equals to 1. So I can rewrite 1 as 2 raised to power 0. So you'd see that the 1 is gone and it became 2 raised to power 0. So everything is 2 to 2 now as its base. Now this part, we have to be very careful. Please, let's pay attention to what I'm going to do. This is 2 raised to power 2, open bracket 2y. Because it is multiplication in indices, if it is multiplication, it is plus. Then 3, open bracket 3y. So remember, the rule is to ensure that at your left-hand side, you have just one base 2, and at your right-hand side, you have one base 2. So I have eliminated the numerator, the basis, to have just one base, but I'm left with a denominator that has a base 2. Division in indices means subtraction, minus. Now what am I going to subtract? 5, open brackets 1 minus y, close bracket, all equal to 2 raised to power 0. So I've succeeded in making the left-hand side to have one base, which is 2, and the right-hand side to have one base, which is also 2. So at this point, you can equate powers. So you cancel out the base, and then you'll be left with 2, open bracket 2y, plus 3, open bracket 3y, minus 5, open bracket 1 minus y, equal to 0. Good. Let's expand. 2 times 2y is 4y, plus 3 times 3y is 9y. Then here, minus 5 times 1 minus 5, minus 5 times minus y. That's plus 5y, equal to 0. So collect like terms. 4y plus 9y plus 5y equal to minus 5 will move to the other side and becomes 5. Here is 0 already, so it doesn't matter if I write it. So let's add them together. 4 plus 9. This is 4y. 4y plus 9y. 13y plus 5y. That's 18y equal to 5. Divide both sides by the coefficient of 18 of y, which is 18, and that gives you this. So y is equal to 5 over 18. That is the solution to the question. Easy peasy, right? Okay, please, you're going to do this for me. Exercise it. You have to solve number 1. 3 raised to power x minus 4 equals to 9x. 9 raised to power x. Number 2, 4 raised to power 2n minus 1 equals to 16 raised to power 2n minus 3. And lastly, 2 raised to power 3y times 4 raised to power 2y divide 16 raised to power y minus 4 equal to 1. Please do this, put your answer in the comment section, and let's see who will be the first to get it. Now watch out for the next video. In the next video, we will talk about logarithm.